Ladies and gentlemen, this is Joe's Classic Video Games back with another cool pinball repair video for you this evening. We have been working on this very nice condition Bally Future Spa wide body pinball machine. And on the previous video, we got the MPU to boot back up. It had a problem with one of the traces on the MPU. And then we noticed that the display voltage was missing, so we were able to get that back by rebuilding the display voltage power supply. On the previous video. We've got the thing where it's booting up and it's got the display voltages, but it's still got some issues. We haven't played it. I haven't heard the soundboard in a while. I think I heard it whenever we were working on it before, but it's not making a peep anymore, so something's going on with that. Might have to work on that. We've got some lamps that aren't working right, and still some of the displays aren't working right. We got the voltage back, but let's see here. Yeah. This one is missing one of the digits. Now the displays, they're flickering and stuff in the camera. It's not really doing that, but if you look, the second player, the tens digit is missing. So that display needs some work. The other ones seem to actually look pretty good and be working fine. So let's pull that display out and we'll look at it first, and then we've got to work on a lot of lamp issues. So here is that display, and you can quickly see the problem right there. Now, sometimes you'll have a problem where a digit's missing or a segment is missing because of this. See the bad solder joints? That one's pretty bad. That one's pretty bad. Okay, okay, nah, okay, okay. It's always the ones on the end. That one's pretty bad. That one's pretty bad. Right, so you need to reflow the solder on that so that they're all making good connection. But these Bally displays, these 6-digit and 7-digit displays, had a particular problem that popped up all the time. Put this little dust cover on. There is a resistor for each digit, and the resistors get really hot. And so this is the ones digit, that's the tens digit. The tens digit is the one that we're having the problem with. So this resistor has cooked itself to the point where it's no longer even allowing current through it. Right? Or no, I'm sorry. R1 is the first digit. R3 is the tens. R5 is the hundreds. R7, notice these are different, is the thousands, 10,000s, 100,000. So why are these different than those? Those may have been replaced at some point, or maybe these were replaced. Let's look on the back and see if we can tell. Those don't look replaced, but neither do those. So I don't know. For whatever reason, these three have had a lot more current through them than these three. So I'm going to pull those off and replace them with brand new ones. I can't ever remember if they're 10K or 100K. I think they're 10K. I have some schematics right here that would tell us for sure. Well, we'll figure it. Alright, so they're 100K, and I replaced them, left them off the board a little bit. You know, this one's getting kind of borderline because that board is so charred up. Eventually, the board itself, the carbon, will conduct, right? But it's still fine for now, but we'll see. And all three of those are fine, so we're going to put it back in. I think I'll move it down to like the 4th position, though, 4th player, so that if down the road these short together and some of them start doing weird stuff, the guy won't have his 2nd player display screwed up. It'll be his 4th player display screwed up. But we'll pop that back in and see if that fixed anything. All right, so that did fix the display. I moved it down here. And again, you're seeing flickering. It's not really like that here to the naked eye. Now, I know what you're thinking. Well, shouldn't you go through and replace all of those resistors? Well, I'm doing this as a business, you know, so it's hard to fix a customer's machine and charge them for stuff that's not broke, right? So yeah, I could. And then I tell the guy, oh, you know that one digit that was missing on your display? Yeah, I had to rebuild all 5 displays. That'll be $150 or whatever, right? So I'm just trying to make a little instructional video here. So we got that going. Next, we need to work with the lamps. There are tons of lamps that are screwed up. Let's see if the soundboard will do anything when I go to the soundboard test, too. Solenoids. Okay. Yeah, I think that's the I think that's the soundboard test. That might be switch test. That's switch test. Yeah, so the soundboard's not working right now either, so we'll have to mess with that. But first, let's do the lamps. Let me put it in test mode, and we'll make a list of all of the lamps that aren't working. All right, so we'll do this one first, since it's... I don't even think there's a test for this. Whenever you do the lamps, I don't think it turns all them on. It might, but you can see how there's two there in the middle that don't turn on. I replaced the bulbs that did not fix them, but all the other ones work. So that board, that little lamp, what did I call it earlier? Blinking circuit is controlled by the auxiliary lamp board. So there is a thing in the manual that shows you which one is which. So here in the manual, it shows you this. And the ones that aren't working are number 4 and number 8, I believe it was, wasn't it? 4 and 8. So 4 and 8, pins 11 and 12, Q7 and Q8, which are Q0 and Q1 on U3B. But see how this says 3B and this says 3A? That's actually the same chip. So there's no real reason that two of those would die right next to each other. So we'll look at it, but it could be Q7 and Q8. Sometimes it's bad solder joints, but in the middle of the connector at pins 11 and 12, that's not usually the issue. So I'll see if I can test these SCRs with a multimeter, and if anything looks weird. And here is the board. So your signals come in from here, from the CPU. They run through this, which is this. And then it runs from there to control two different chips that have two different sides on each chip. So it's these. And then those chips control all of these SCRs that turn the lights on and off. Easy peasy. Now let's see if we can figure out what's wrong. Alright, there is some bad solder joints, but nothing around 7 and 8. So it's 1, 2, 3, 4, 5, 6. It's this one and this one. Pins 10 and 11. Well, actually, that looks pretty bad, doesn't it? It's that pin and that pin. Yeah, hell, that might just be a solder joint thing. Usually it's the ones on the end, but on that does look like they're broke loose right in the middle of the connector. Wow. Okay, so I'm going to just resolder them first, and we'll try that and see if that fixes anything. I did test the two SCRs. I haven't had good results testing those with a transistor test. They all test fine, but a lot of times one will be bad and test fine. Usually whenever I do this, the problems are solder joints, and then these chips go bad, which are 4555s. So yeah. Alright, yeah, so let's try new solder and then put it back in. Sure enough, it was just bad solder joints. Alright, well, in the spirit of that, I think what we'll do is we'll just pull out the lamp driver board for the other lamps and hope that they're all that too. But you can see, like, on the playfield, a ton of the bulbs aren't working. So we'll pull that board and make sure all of that looks good on the back of it, and then we'll put it back in and then test all the bulbs. Well, this board has been extensively repaired. Basically, these sit in the back box right underneath the MPU, and at the bottom of the MPU is where that battery is. And so the battery alkaline leaks out of it. Sometimes you'll see like a drip on stuff, but I've recently discovered that there's a gas as well. They say that it actually releases fumes, and the fumes can corrode too. So if you look at the front, So imagine the batteries right here that's leaking. They all leak. If you look at the front, that's pretty typical. You see corrosion on the legs of some of them. And notice although it's farther down, it is right under the center of the board where the battery is. So I got a little corrosion on that one, a little corrosion on that one. Typically though, whenever they have that corrosion, they will still work. A little corrosion on that one. Notice it's the left one. That must have been like the exact area it was leaking at. And the ones at the top, strangely, aren't like that. So I don't know if that means that something dripped down and then hit the board or something. I don't know what that means. And then if we look at these, they actually have no corrosion at all. Okay, if we look at the decoder chips, they don't have any corrosion either. So everything looks pretty good on the front except for some of these having a little corrosion, but like I said, you see that on all of these. But then if you turn over on the back, you see what's going on. So this is where the CPU connects, and it controls these 4 decoder chips, right? And then they turn on and off these SCRs, right? And the SCRs turn the light on or turn it off. So if you've got a light that's never on or it's always on, you've usually got a problem with one of these SCRs. If they're not on though, sometimes it's because the SCR on the board is not actually connected to the light because of a connection problem on the connectors or what's going on with this one. So this is the bottom of the board, this is the top of the board. You can see that the way they routed a lot of it was, see these little, those are jumpers, it's hard to see from the back, but these little jumpers come up and then a trace goes around the edge of the board over to a certain pin, right? And by doing that, sometimes they route the SCRs or they turn on 2 lamps. So this is the connector that goes to the back box, and this is the connector that goes, these 2 connectors go to the playfield. So it could be that it's the light that says like, same player shoots again. There may be one on the back box and one on the playfield. So the SCR could be fine, but it's just that trace is messed up, and it's these ones around the edge that always get screwed up. And you can see down here it's pretty rough too. Some of them may not be connected anymore. And that's what these jumpers are. It's a jumper wire that is connected, you know, that's connecting some stuff together that is screwed up. I don't know if I did those or if the previous repair guy did them or what, but I'm about to do some more because I gotta test all these traces and see if any of them are broken, and if they are, run a jumper. So you can buy a new one of these boards. They're about $100 for a brand new one. And there's so many used ones out there, you can do a used one too. I don't have any used ones in right now, any that are working, so I don't think. So I'll try to fix this one, but if I can't, we can swap another one in. Well, they're actually all connected. So I've carefully measured each one, and you know, they wrap all around the board and go through little jumpers and everything, and it's just the ones on the very edge that are screwed up, and those have been fixed by those 4 jumper wires. So so that doesn't have anything to do with it. So I believe we need to test all of these SCRs. Like I said, I usually can't test those that well because they'll test fine, and then whenever you put them in the game, they still don't work. Could be connectors too. Maybe some of the pins on the connectors are messed up, and it could just be bad bulbs. But we'll do as much maintenance on this as we can and then put it back in. Alright, so I went through and I replaced all the bulbs that were burnt out, and that got a few of them back, but a lot of them still aren't working. So we've got the 9000 over here and the spots letter when lit. We've got the special and the targets spot letters when lit there. We've got the F and the R and the special there that don't work. We've got the 8000 up here that doesn't work. We've got the F and the R up there that don't work, which seem to correspond with the F and the R down here that don't work. So maybe So I'm going to make a list and then we'll check them out. Okay, we've also got this one, whatever it is, that doesn't work. And in the back box, if you notice, those two aren't working again, and the one on the right. But I think that's because in the test, it can't test those or something. It doesn't test right in the test mode. Oh, and also the gate 3000 when open. I think that might actually be on the relay. Maybe if I open the gate, it turns it on. I don't know. So yeah, I'm going to write all them down, and then we'll look in the manual and see if all of them have anything in common that would explain why they're all out. Okay, so I've written down every one of them that doesn't work. And so the reason I do this, one, so you can make sure every one of them works, but because it's kind of fun to me to compare them to the diagram in the manual. So if you start looking at them, it's all of these, and then it's a few of these. And they all trace back to this chip. So everything that comes out of this chip doesn't work. And then there's a couple more that are spread around that might be a bad socket or, you know, a bad connection on the wire or something, but the vast majority of them are right here. So for instance, these are the SCRs that it controls. So Q47 does not work. Q43 does not work. Q45 does not work. Q57 does not work. Q50 does not work. Q51 does not work. Q54 does not work. Q55 does not work. Q60 does not work. Q59 does not work. They're all on my list. So this chip is just completely dead. And that chip is a binary to 1 of 16 decoder. I've been seeing more and more of those die over the last couple years. It used to be you never had any problems with those, but time marches on, and it's pretty much got to be that. It could be maybe this strobe line here, but if you look, it's going to all of the chips. And then I guess it could be this PD3 line. Which is coming from this resistor pack, I guess, or no, ultimately it's coming from the connector. So I guess you could use a logic probe to see if you've got a signal on PD3, which is going to be used to turn on U4. The address lines are shared by all of them, so it's not really going to be that. It could be PD3 though, if that was out. If that one line was out, it would kill all the outputs. So maybe I'll check that, but I think ultimately this chip may need replaced. A logic probe. So it's pin 23 is the enable chip. Or I don't know what it is, but it needs to be there. So that's that one. That's that one. That's that one. What? What? What has happened? All right, so we're missing a signal. All right, so the way we should be able to figure it out is to just look at some of the lights that are screwed up and wiggle the connector. It still could be the chip, but I doubt it. All right, that connector's not doing a thing. So somehow we're losing that signal somewhere. Interesting. I haven't seen that much. All right, so let's see where it comes from on the MPU. So this is the MPU. AD3 is J1 pin 12. Which we could check on, see, 48, 49, 50, 51, 52, 52. No, I went backwards. C41, 42, 43, 44. C44. So if we find C44, we should have activity on C44 on the MPU. C44, see if it's twinkle, 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 little star. C44 is right there. Okay. Whoop. Yeah, we got it all on the MPU. And then it runs into that connector. That connector is a insulation displacement connector. Those suck. So it very well could be that connector. So I don't want to risk moving that, because if you basically the signals that go to your displays, if you interrupt those, it can screw up the displays. There's a little chip that catches the signal on the display, and it doesn't like that. Maybe I'll find that one wire and try to wiggle the one wire to confirm that it's a bad connection on that connector. Well, it was a solder splash on the connector on the back of the lamp driver board. Pin 4 is actually the data line, not the address line. So it was a solder splash on the back of the board. Pin 4 was connected to pin 3, which is 5 volt. Now, the strange thing is, you would assume that I just did that because I just reflowed the connectors. But if you go back to the beginning of the video before we even messed with it, none of those lights worked. So I don't know. Maybe that has been like that for years or something. I don't know. And also in the test, that thing up top does work just fine in test. So I don't know. Whatever. I guess the address line being shorted, or the data line being shorted on the lamp board, was screwing that up again too. But yeah, we got all of our lights working, so that's good. So next thing, we need to figure out the soundboard. It's not doing anything. There's a soundboard test. That's the soundboard test. It's not doing anything. So yeah, so first step on that would be to pull it out and clean the ROMs and things on it to make sure that the sockets are reading the chips properly. This thing has cool sound effects too. This is that one where when you boot it up, it does all of the stuff where it sounds like it's just garbled and screwed up. So let's pull the soundboard out. All right, so here is the soundboard. This is actually very similar to the one that is in Xenon. Not the speech part, the one of them they call this, I think it's the Sounds Plus and the Vocalizer. It's not the Vocalizer part, I guess it's the Sounds Plus. I may have that wrong. But this is really similar to that. You can see on the schematics too. So it is controlled by solenoid lines that come from the MPU. Which run to a AY38910, which is a music chip, sound chip, right? But the board itself is like a self-contained computer. So it's a 6802 MPU, CPU. This is your RAM. This is a PIA, peripheral interface adapter chip. No, that's your RAM, and that's your ROM. I guess this says C notes because you can put different size ROMs in it, depending on the jumpers. So you've got CPU, RAM, ROM, peripheral interface adapter, which I guess is used. What are they controlling with that? Oh, it's how they're controlling this, the sound chip. Very cool. So this is before they did speech at Bally. and it says 79. Very cool. All right, so what I'm going to do is my number one suspect on this. Whenever we did the previous video, there was some sound. Whenever you turned it on, you heard sounds and stuff. Now that you don't, this is the number one suspect on any Bally soundboard, the volume pot. So that thing, it just gets in a spot where it's not connecting well, and it doesn't conduct, and then it kills all the sound. So if you turn it, did you hear how it just went and popped loose? So now it won't do that anymore. So now it moves freely. So basically what happens is it's stuck in a certain spot, and you get oxidation and resistance on that spot, and so it no longer conducts. So I'll show you why that is a thing. It's just the way they've designed the circuit. It's old school stuff. So all of your audio is coming from two places. This is the speakers here. One place it's coming from, or I don't know if audio is actually coming out of here, but this is a signal to turn it on, basically. I guess that probably just makes it conduct, but this is your audio output from the 8910, right? So it comes out now. I guess this controls if it's on or off or whatever. And then it runs into this preamp. These 3900, this LM 3900 preamp, those are known for going bad too. But look, once the audio comes through here, through the preamp, it runs into the volume pot. And then if this wiper on the volume pot is not making good contact, or it has a lot of resistance or whatever, that audio will just stop right there. And it will never go and be amplified by the amp and go out to the speaker. So everything runs straight through that volume pot. On some things you have the volume pot is adjusting something on the amp or whatever to turn it up and down. But on this, it runs straight through the pot. So without that pot conducting well, you would have that problem. And you saw when I just turned it, you heard it go click, right? That was me breaking it loose from whatever position it's been stuck in for probably 20 years or something. Right? That alone may have got it going, but I'm going to replace that pot and put a new one on it, just because it's a really common failure point. So I think what we'll try is just replacing the pot, see if that gets us back up and going. But if you look right here, look at this. That's a 1 microfarad capacitor that all of the audio also runs through. So if that capacitor gets to the point where it's not doing it's not capacitating, same thing. The audio is just going to stop right there. It's never going to get amplified, and it's never going to come out of the speaker. So if this cap's screwed up, well, you still might get something out, Here's another one, though. Look, if that one's screwed up, nothing's going to come through. It's just going to completely block it. Now, these ones that are a little bigger, it's a 220, you usually don't have the problem. But these little 1 UFers, they screw you up a lot. So I think what I'll do is I'll do the volume pot first. We'll see if that fixes it. If it doesn't, we'll try that one next and see if that fixes it. What do you think about that? All right, so I replaced the potentiometer. Let's see if we get anything different. I can definitely hear the volume. So probably because I turned up the pot. Yeah, but no audio. It plays this real screwed up intro tune. It sounds like the thing's dying. And on some of these you can press this button and it'll do a test thing. Pretty wild. Okay, so yeah, we're not getting any audio. The bzz, bzz you're hearing, it's through the speaker, and it's the lamp strobing. Okay, so let's try replacing that one capacitor and see if that does it. That capacitor didn't fix nothing. So then I tried the next capacitor, and that didn't fix nothing. So I've been working on this for like 2 days. And I didn't film all of it because I didn't know what I was doing. So, I don't like to film things. And yes, I said film. I don't like to film things if it doesn't work. You know, I mean, it's not helping you much to watch for an hour as I stumble through something. So I think what I'll do, I did fix it though. So I think what I'll do is I'll show you kind of how it works, which I was able to kind of get a little bit better understanding of, and then that way you can figure it out on your machine. So this is Future Spy. It was only the second board, the second machine that had this board. I've been working on this for 2 days. This is the A8 computer sound module. It's also known as the Dash 51 soundboard. And I was mentioning before that it's very similar to the Xenon soundboard, which is called the Sounds Plus soundboard. And that was the Dash 56 soundboard. It's very similar. They just added the ability to have that extra board that does the speech on Xenon. So the way this works is, since this is one of the first games that used it, the self-test doesn't do anything. So on the first 3 or 4 games, if you hit this switch, it doesn't do nothing. That's the NMI, or not NMI, right? So whenever you hit that, it's not going to make it do anything on this game. However, you can go into the test like we did before, go to position 4, I think, on the test button in the coin door, and it gets to sound test, and it just plays the same sound over and over and over again. But you can use that to test. So the way the thing works is, since that button doesn't do anything, basically the CPU, there's no way to trigger the sound from the board. The MPU has to do it, which is basically how it works anyways. But so the MPU of the whole game connects over here to this sound chip. It's a Yamaha AY38910 sound processor. Okay, and there are actually 5 different solenoid addresses that connect to this thing. I think only 4 of them are actually used on this game. The 5th one I don't think's hooked up, and the one that says spare, I don't think it's hooked up either. So I think just A, B, C, and D actually come from the CPU. Now it says that this one does too, but I don't believe it does. So those 4 lines go through this 4049 chip and basically talk to this Yamaha sound chip. Okay. There is also a signal that comes from the CPU that's called a sound interrupt signal. And what that's doing is it's just turning on this 6821, which is a peripheral interface adapter chip. It's turning it on and off with this line here. So that will either go high or low. I don't know which one does what, but you'll see action on that from the CPU, the MPU in the game, and you'll see action on these 4 solenoid address lines. Okay? And so the CPU tells this sound chip, play a sound. Okay? And depending on which solenoid address line goes high or low or whatever, it's sending it basically a code, right? So this chip, then, I believe this is how this works, some of you can probably correct me, uses this BC1 and this B direction line here to talk to the PIA. This is the peripheral interface adapter chip. And if that line is high where it's supposed to do what it's supposed to do, it talks to this chip. This chip basically talks to the CPU on the board, which is a 6808 as we found it, right? The 6808 talks with the ROM, and it also talks with the RAM. And so the 6808 is able to access the ROM and get information out of the ROM about what it's supposed to be doing with this sound chip. So this sound chip, can play melodies, can play all kinds of stuff. And so this ROM chip is telling the CPU what to do to this chip to make it play all of its stuff. Okay? So the main board in the pinball machine talks to this sound chip, but is not able to make it do anything. All it does is talk through the PIA chip to the CPU on the soundboard. The CPU on the soundboard goes, gotcha, and it starts talking to the EEPROM. Of course, it needs to use the RAM to do that. It starts talking to the EEPROM, and then it, again, instructs the PIA chip to talk to the sound chip. So the PIA chip has all of these data lines here that it's able to talk to this chip with. And it tells this chip exactly what to do. Okay, play an E for half a second. And then play a little glissonamo. I don't know. It tells it to play something, right? This chip has 3 different outputs, A, B, and C. But on this board, they're all tied together. So once the PIA tells it to do something, this chip sends out sound. Okay? It goes into this preamp 3900. I think this is used to turn it off or lower it or something. I don't know. It might adjust the volume. We were talking about that earlier. It goes into this preamp. The preamp goes through the volume control. Then it goes into the amp and out to the speaker. Okay. So my whole point is, this CPU is not really running everything. This is running everything. So the MPU telling this chip to go ahead and do something is what starts it all. It kind of works backwards. Then this chip talks to the PIA, which talks to the CPU. That's why they call it a peripheral interface adapter. It basically can go both ways, right? So CPU talks to the sound chip, which talks to the PIA, which talks to the CPU. The CPU then looks in the EEPROM to figure out what's going on, you know, what it needs to do. You know, the EEPROM code is running the CPU and telling it what to do. So it, you know, if this chip says, you know, whatever, we'll just make something up. If it says a number like 1, this goes, what's 1? And it looks in the EEPROM and figures out what 1 is, and then it tells the PIA, do 1. The PIA tells the sound chip, do 1. The sound chip outputs the sound. Okay? So that's basically what's going on. I swapped out all of the chips, didn't fix anything. They were all socketed. I then checked this chip and it seemed fine. I swapped it anyway, and it didn't fix anything. There is also a chip here that's a 4011 that's involved with the reset circuit. So basically when the game starts up, when the soundboard starts up, the reset line is held low and then goes high after a split second. That was working fine, but I thought, well, maybe something's not right, because no matter what I did, I couldn't get any sound out of the thing. That had nothing to do with it. As long as that's going high, you're good. So the CPU had action on the address lines and the data lines. I checked the ROM. The ROM was fine. I burnt another ROM, same problem. I changed the PIA. That was fine. I changed the RAM over and over again. That was fine. I couldn't figure out what the problem was. But what I eventually did was I took the 6808 out and put in a 6802. The difference between a 6808 and a 6802, I know this is deep in the weeds, but I'm just trying to tell you everything that happened, so in case you decide to want to try to fix one of these. The difference between a 6808 and a 6802 is the 6802 has internal RAM, so you don't need this RAM chip. Okay? So I don't know if my 6808 was bad. I did try another one, but maybe both of them are bad. But if you use jumper A, you will use the internal RAM in the chip, which is a 6802, and you don't need U10, which is the RAM chip. If you use jumper B, you're telling it you're going to use external RAM because you have a 6808, and it's going to need U10. U10 is a 6810. I've got tons of those. I tried 6 different ones, didn't change a thing. Okay, I ohmed out the socket. All of the sockets seem fine. Same on all of the sockets, right? I tried 2 different 6808s and had the same problem. But I finally swapped in a 6802, changed the jumper, and that fixed it. So it's up and running without the 6810 and with a 6802 installed in it. So there's the board. That's the 4049. I replaced it. Didn't change anything. That's the 4011 that is involved with the reset. Replaced it. Didn't change anything. That's the LM3900, the preamp. Those go bad all the time, so that's probably a good preventative thing to do. And of course, we already put the pot in. This is the 6808. I mean, 6802 now, but it was a 6808. If you put that in the 6802, you don't need the RAM, the 6810 that was here, but you have to move this jumper. There's the EEPROM. It's a 2716. That is the PIA. It's a 6821, and there is the Yamaha sound chip. AY38910. I guess it's a Yamaha. Maybe Yamaha developed it. For whatever reason, I think it's a Yamaha. Now, you're in for a real treat. Oh. I thought somebody was coming in. They're not. Since this was only like the second or third game that used this computer soundboard, it was pretty early in the whole idea of that. So it's 1979. I'm going to do this 2 or 3 times just for the crap of it. When the thing boots up, it plays a little melody. Okay? Wait till you hear the melody that it plays. So this is what it plays when the game boots up. So this is all going to do the 7 flashes, and then finally whenever this boots, the software is going to say, hey, play a melody, and it's going to tell the soundboard to play something. So this is what they chose to play when the game boots up. So it's got to do its 7 flashes, and then you'll hear it. Okay, so that sounded horrible. Surely the game is screwed up, right? Surely that's not how they intended that to sound. Oh, no, that's exactly how they intended it to sound. So if you have one and you're trying to fix it and you want to know what it's supposed to sound like, this is what it's actually supposed to sound like if it's completely working perfect. That's as good as they could do. It's amazing. Okay, I'm going to do it one more time just because it's awesome. So when you turn on Future Spa to show off the power of the computer soundboard, this is what they chose to play with the Yamaha sound chip. Unbelievable. So Future Spa apparently was based on Bally wanted to get into the spa business, which they eventually did, or the fitness business. And in my opinion, it's one of the best back glasses ever. Just look at it. It's a masterpiece. This is how pinball is supposed to be. Let's see who did it. I'm going to look it up. Let's see who did Future Spa, the back glass. I'm going to say it was Christensen. I'm just going to guess Christensen. I'm looking it up. I'll let you just marvel at it while I look it up. It was Paul Ferris. And Christensen did some of that art. Who knows who did what? Let's see. Paul painted the back glass. Paul Ferris did the back glass. Dave Christensen did the artwork on the playfield. Look at that. Easily one of the best back glasses. Okay, so I've done videos of playing this before. We just need to test play it a little bit. It's a wide body, or I think Bally called them super wide bodies. There is a button installed on the coin door of this particular game to add a credit, and this is what it sounds like when you add a credit. So when I hit that, the CPU is reading that a switch was pressed, and then it's saying, hey, play a tone. It's sending solenoid signals over to that soundboard and talking to that sound chip, which, by the way, was General Instruments, was not Yamaha. So that's another interesting thing. Most people don't watch the whole video, so you're going to see like 50 people tell me that it wasn't Yamaha. When if they would have waited 4 minutes, I corrected myself on the video. But that's all right. That's okay. That's what life is for. They're just being helpful. They didn't notice all the other things I screwed up, or they'd correct that too. And it's telling that chip, the General Instruments chip, to play a tune. The chip is talking to the PIA, which is talking to the CPU on the soundboard, which is looking in the ROM to see what it should play, which is then telling the PIA what to tell the sound chip. It tells the sound chip a bunch of information, and the sound chip goes... All right. It has background sound too. You can turn that off if you want, but why would you do that? Perfect. Look at that. That's skill, folks. Oh, come on. We got the tilt set too tight. This thing's loaded. Look at it. It's got a kickback on the left. Whoa. It's got 5 pop bumpers. Oh, got the drain there on the right. It's got a kicker over here and a kickback over here. It's got 6 rollovers at the top. Got a nice spinner shot. Ooh. It's got the horseshoe shot from 8 Ball on the right up there. It's got 4 inline drop targets. And it has the computer soundboard. Oh, it's got a spinner on the right, too. Oh, it's on 5 Ball. In my opinion, this is a very underrated game. The theme is awesome. Now, if you want your themes to be, you know, Spider-Man, then yeah, the theme isn't any good. But if you want your 70s pinball to look like a 70s pinball, this is the theme you want. Ooh, that was quick. That was fast that time. Ooh. Oh, I got an extra ball that last time, I think. Didn't it say shoot when lit on the previous ball? Shoot again when lit. Whoa, no. Oh, no. There we go. A little rubbing will get it all right. You can bounce it over that hole if you do it just right. I think my F wiggled off. I think the F is supposed to be lit up. That's 3. Kind of a similar layout to Space Invaders. Cool soundboard, though. I love it. Cool. Our F came back on. We won 3 free games. All right, folks, so there you go. That is Bally's Future Spa. Working well. Going to send it back to the customer. I think he'll enjoy it. This was actually his father's game. His father passed away a while back. Joe was reminding me of that. So this has been in his family for a long time. I don't know if they bought it new or what, but they've had it a while because the thing obviously is in very nice shape for this title. So I hope you enjoyed it. Leave your comments below and let me know what you think. Make sure to give us a thumbs up for taking the trouble to film it for you. And you know where you can see more of our great videos? If you check out my brother Donnie, he has his own channel here on YouTube where we work on old mobile homes, old buildings, vehicles, things like that, and he has a farm. So I'll see you over there. But if you really like, if you just love this Future Spy and you can't get enough of it, here's another video of it. You can check it out here. We'll see you on the next one.